Okay, Chapter 2, Introduction of Microgrid. Here is the outline. First, I will introduce what is microgrid, and followed by the components in microgrid, what is the pros and cons of microgrid, and who needs microgrid, and what are the activators for developing microgrid, and finally, the microgrid in remote area. So first, what is microgrid? The word microgrid can be separated into micro and grid. And the grid means the microgrid is the power grid. So it consists of generators, power lines, and loads, just like the traditional grid. And the word micro means the scale of microgrid is small compared to the traditional power grids. So what is microgrid? I will say microgrid is a power grid covering a small area and enable to integrate distributed power sources. So here is the components in microgrids. The microgrid consists of PCS, PV, wind turbine, other green energies, diesel generators, utility, ESS, and the load. And all these things can be controlled or monitored by the EMS. So for the first, in the following slide, I will introduce each component gradually. And the first is the green energy. We usually use PV and wind turbine in the microgrids, and they serve as the power source of the microgrid, and usually is the first priority power source. And the second is the utility and the diesel generators. They also serve as the power source of the power microgrid, but they are usually the less priority power source. The power from the utility can also generated by diesel generator, or it can be generated by the traditional power plants. And the major difference between microgrid and traditional grids is the generators, or more precisely, the power source. In traditional grids, the power source can come from nuclear power plant, fossil fuel power plant, or hydroelectric power plants. And in microgrid, the power can come from the utility, which means it's the same as the traditional grid. But besides the utility, the power in the microgrid can also come from distributed energy resource, DER. So DER including the PV, the wind turbine, or other green energy, and ES, energy storage system, or electric vehicles, or diesel generators. These are all distributed energy resources. And the ESS, energy storage system, it can serve as power source while it is discharging, and serve as load while it is charging. And so it's very flexible. Its function is very flexible to the microgrid. And the ESS is usually consists of batteries because it has little restrictions on consumption location, and the battery is also easy to move and easy to store compared to other storage system. But the energy and power of one battery cell is too little, so we usually connected battery cells in series or in parallel. So the battery cell will connect it into a module. The module will connect it together to become a rack, and the rack will connected together to become a ESS system. And we usually will put the battery into a container like this. And so when we put the battery in the container, then it is very easy to be moved and can be placed anywhere. So there is little restrictions on the construction locations. And I will introduce to you what is series connection or parallel connections. In series connection, the total voltage is the sum of each unit, and the total current is the same as each unit. And in parallel connection, the total voltage is the same as each unit, and the total current is the sum of each unit. Let's take a look at some examples. Assume the voltage and the current of a battery is 12 volt and 10 ampere. And in this case, we connect 4 batteries in series, which means the negative is connected to the positive of the next battery, or in other words, the positive is connected to the negative of the previous battery, and the positive of the first battery and the negative of the last battery are the output, are the total output. So the voltage of the total output voltage will be 48 volts if we connected these 4 batteries in series, because each battery voltage is 12 volt. So these 4 voltage sum together, then the total voltage will become 48 volts, and the total current will be the same as each battery, which means is 10 ampere. And if we consider the case of parallel connection, then just like this case, we connect these 2 batteries in parallel, which means the positive of these 2 batteries are connected together, and the negative of these 2 are connected together and connected to the load. And in parallel connection, the total voltage will be the same as each unit, which means the same as each battery. So the voltage will be 12 volts, but the current will be the sum of each unit, which means 10 plus 10 equals to 20 ampere. And we usually call this connection to be 4 series, or 4 series 1 parallel, and we will call this connection as 2 parallel or 1 series 2 parallel. And let's consider another case. In this case, we connected these 4 batteries in series and connected these 4 in series, and then we connect these two in parallel. So the connection of this connection is we will call this connection as 4 series 2 parallel. And in this case, the total voltage of these 4 battery is 48, and for these 4 is also 48. So if we connected these 2 in parallel, the total voltage is also 48, and the total current of these 4 battery is 10 ampere, and this 4 is also 10 ampere. So the total current of this connection is 10 plus 10 equal to 20 ampere. This is the series connection and parallel connection. And the next component is the PCS. the PCS is the machine that can convert AC to DC or convert DC to AC for the ESS or maybe a PV, and it will convert AC into DC when we want to charge the ESS by the utility, and it will convert DC to AC when we want to supply power from the ESS to the load. So as I mentioned before, the power supplied by the utility is AC, and the power consumed by the load is also AC, and the power supplied by ESS and PV are DC. So for small PCS, for example, the rated power less than about 10 kilowatts. Some of these PCS are hybrid PCS, and which means the PV may be directly connected to these PCS. And in this case, the PCS will also convert DC into AC when they want to supply the power from the PV to the load. From PV to the load, it also will convert DC into AC. For large PCS, for example, the rated power is larger than 100 kilowatts. These PCS may be controlled by advanced external controller to improve the power quality or system reliability and stability. And the final one is the EMS, Energy Management System. The EMS can collect real-time data of all the devices in the microgrid, and it can also display real-time or historical information on the human-machine interface (HMI). And for some EMS, it may also allow the operator to control the device remotely, or it may regulate all the power source based on the control logic written in the advanced controller. Here is an example of the EMS. So the operator can monitor the system on the screen of HMI. It can also monitor the system at home, which means very far from the microgrid. So it is very convenient for the operator. So here, so far I have introduced what is microgrid, and now I will introduce what is the advantage and the obstacle of developing microgrids. There are a lot of advantages of microgrid. For example, the construction cost is lower because the scale of microgrid is smaller than the traditional grids, and because the scale is smaller, so it is more easier to find place to install the microgrid system. And the second one is the microgrid can supply electricity to the load during power outage, and it can also increase help in increasing the penetration of renewable energy, and it can maximize the use of distributed energy resource. For example, the ESS or diesel generator or other green energies. And finally, it can enhance the power quality and the system reliability or stability. And there are also some obstacles to developing microgrids. For example, the payback period is too long for some customers, and the technology of microgrid is not mature enough. Next, I will talk about who needs microgrid. And people who have no electricity to use may need microgrids. And so far, in 2020, many people in developing country or developing country still do not have electricity to use, because in this country it is very lack of infrastructure, so people still don't have electricity to use, and it's very inconvenient. And people who have expensive electricity to use also needs microgrids. For example, for some people in remote villages and small islands, they will use diesel generators for the power source, and the generation cost is very expensive. So in this case, after building microgrids, the electricity bill may be reduced. And third, the people want to prevent power outage. And for example, some people who suffer from natural disasters like typhoons or earthquake or some other disasters, or for some place that power outage often occurs. In this case, the power reliability of the system may be very bad, so the power outage will often occur. And the third is, for example, for the military base, it is very important, because if there is no electricity to use, then the military will be in very danger. And the fourth is the people want to ensure power quality and system's reliability. For example, for some companies or some industries, the water quality is very important, and also the system reliability is also important. There, the power quality and the system reliability should be very well, and in order to make profits. So the last one is people want to protect the earth, and they may also need microgrids, because the microgrid can reduce the air pollution and reduce the CO2 emission, and to fight against the global warming. So it can enhance the environment sustainability, and it can also deal with the problem of the exhaustion of fossil fuel. So it can enhance the energy sustainability. So why should we develop microgrid? First, we develop microgrid for a better living standard, and the second one is for energy safety and reliability, and the third one is for the sustainability of energy and the environment. Next, I will introduce one other activators for developing microgrids. In the past, the green energy and the technology of green energy and energy storage is improved, so it is more mature in the recent years. So the price is decreased. The price of energy storage is decreased, and the price of PV and wind turbine is also decreased. So they are the activators in the past, and in the future, the price of green energy will keep decreasing, and the fossil fuel will increase, because the fossil fuel is exhausting now, and many people are predicted that the fossil fuel will be empty in maybe 2050 years. So in the long term, they are the activator for developing microgrids. And for some institution like international organization like IEEE, it can also set some technical standards on the elements in the microgrid. So it can help to improve developing of microgrids. And for the government, it can amend the laws to improve the investment environment and offer some subsidies to the companies that develop microgrid. And for the deep utility, it can charge the customer based on the actual power generation cost, which means charged by time of use pricing. And in this case, it will help develop the microgrid. And finally, I will introduce the microgrid in remote area, and which is the case in Indonesia. And the microgrid in remote area will be placed in remote villages or small islands. And the purpose of developing this kind of microgrid is to supply electricity for daily life use. For example, for the light or for the electrical fan. And in this case, the power is not necessarily to supply power all day long. And some people in this area only need some power to improve their life standard. And the second purpose is to supply cheaper electricity, because in this case, some villages or some small islands are provided power by the diesel generators. So the generation cost is very expensive. So after building microgrid, the generation cost can be reduced. And the characteristics of this microgrid is that the system is simple and easy to install, and it is not necessary to be connected to the utility, and it is very promising in recent years. For example, in countries with many islands, like Philippines, Malaysia, or Indonesia, or in countries with many remote villages like India or Sub-Saharan Africa. So here is the common architecture of remote microgrids, and the load can be divided into two parts. First is it can be supplied directly by the utility, and the second is supplied by the PCS. And in this case, the utility and the PV and the battery all of these three can supply power to the load here by the PCS. And among them, PV power is usually the first priority to the AC output or PCS. And after building remote microgrid, for individuals, he or she may spend less on electricity and may less suffer from power outage. And for example, if we build a PV system with the capacity of 10 kilowatt, then and also assume the average installation is 5.18 kilowatt hour per meter square per day, then the electricity bill can be saved $497 per month. Assume the generation cost is $0.4 per kilowatt hour. And for the whole community, the environment can be better because the air pollution can be reduced and the CO2 emission can also be decreased. And the education and medical level can be enhanced, and the economic development can be boosted. And in this case, the CO2 emission can be reduced about 5,000 kilograms per year. And these are the expected benefits of if you build the remote microgrids.